Exercise number 1 says, find the number 1/3 of the way from 1/6 to 4/5. All right? So the first thing I'm going to do, I just like drawing my number line, give me a sense of where I am. Okay? I know that 1/6 is here and 4/5 is here. Okay? Now, this is the full distance, right? Bless you. But they want the number only 1/3 of the way. So if I divide this into thirds, they want to know, what's this number? Okay? If I go from here to here. Well, the first thing I'm going to do is I'm going to find out how big the full distance is. All right? And I'm going to do that by subtracting. So 4/5 minus 1/6. I need a common denominator, which is 30. Okay? That's going to be 24 in the numerator there. What's the numerator here? 5? 5? Okay. So I'm going to get 19/30. Now remember, that's the full distance. That's from here. That's from 1/6 all the way to 4/5. Okay? Now, I'm going to divide this by 3, which is the same, Parker, as multiplying by 1/3. You agree?
You can do either one yet.
I don't want to do either one. I want to multiply by 1/3. Because I've got a fraction here. And when I'm dividing a fraction, divided by 3, what do I need to do? Multiply by the reciprocal, right? Okay? So multiply by 1/3, and that's going to give me 19/90. Okay? Now that's how long that distance is. That's not what this number is. Okay? That's just 1/3 of the distance. So I need to add that to 1/6. So 1/6 plus 19/90. Okay. What's the common denominator, Drew?
Oh, 180.
Not 180, but 90.
90.
Okay? 6 goes into 90 15 times? 15 plus 19/90. What does that give us? 34/90. Now I can reduce that, so I need to.
1745.
17, thank you, Cameron. 17/45. So 17/45 is the number 1/3 of the way from 1/6 to 4/5.
Why would you add 1/6 to 1980?
Because remember, this is 19/30 the full way, right?
I think it does.
We subtracted 1/6 from 4/5,
Right, okay.
right? And we got 19/30.
So it's the full
But
way.
then we wanted only 1/3 of the way. So we divided 19/30 by 3,
Okay.
and we got 19/90. So that's 1/3 of the distance. But they won't want to know what 1/3 of the distance is. They want to know what is the number that's 1/3 of the distance from 1/6. So since I went from 1/6 to the right, I have to add 19/90 to get 17/45. Find out what that number is. Okay. All right. Let's look at the next one. Express 0.5 with 4/2 repeating, okay? 0.5, 4/2 repeating as a fraction in simplest form, okay? So the first thing I'm going to do is I'm going to say, okay, x is going to equal 0.5 and then the 4/2 repeating. Now, how many digits are repeating, Dylan? No, two digits. Yes, it is repeating, but 2 of them are repeating, right? So I'm going to multiply x by a 1 with 2 zeros behind it, because there are 2 digits repeating. So 100x is going to move that decimal point 2 places, so I'm going to get 54.24 repeating. Okay? Now once I've done that, I'm going to take the x where I started, and I'm going to write it underneath, and I'm going to subtract. Okay, but remember when I'm subtracting, I have to line up my decimals. So that's 0.54242 dot 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 going forever. This is 54.24242 repeating. Multiplying by that 100, put the digits right under each other. Right? Yeah, that's
Wait,
good.
sorry, go back to the 100x.
Yeah.
Where did it go?
I don't know what you mean. Where did it go?
After, between the second step and the third step. No, you're.
This is a subtraction problem, SK.
What is x? Oh, you're just subtracting the original.
I'm subtracting subtracting the original. I probably shouldn't have written them that close. That's okay, that's my fault. Okay. So now, 100x minus x is 99x is equal to, now when I subtract, you can see these just cancel out all the way, except when I get to here. Okay? Now it's 54.2 minus 0.5. I'm going to borrow from the 4 and make it a 3. 12 minus 5 is 7. 3 minus 0 is 3. 5. So now I've got 99x equals 53.7. Okay? Divide by 99. Now x equals something with a decimal.
0.542.
No. Please read the directions. We want it as a fraction in simplest form. Okay? What do I do
You should go in the three.
to get that, Carlos?
Multiply the numerator and denominator by 10.
Multiplying by 10, because all I need to do is move this, that decimal one place, right? That goes 1, and that goes 1. So I'm going to get x is equal to 537 over 990. They are divisible by 3. Good. So 3 goes into 537. Anybody? I don't know. 179? Okay. 179 over 330. Okay. Does anything go into those two? I don't think so. We'll leave it like that. Check it. Divide 179 by 330 and see if you get 0.54242424242. Is that what you got? Nice. Nice. Okay. Another good job. Let's look at the next one. Oh, isn't it nice? It's like going back to preschool. Someone asks me how to spell your name, which I'm assuming you know how to do. Okay. Allie, what do you think?
By factor 245.
All right, let's factor 245. What goes into both of them? Remember, it's going to be 6. So 6 times what? Root 5 times root 49? Okay. Thank you, Sophia. So it's 6 times root 5 times root 7 times root 7?
Yeah.
Is that right? What happens to that?
That becomes
7
7.
7.
So now it's 6 times root 5 times 7. Can I do anything with the root 5?
Nope.
No. So what do I get? What's my final root 5?
42 root 5.
42 root 5. Nice job. Boy, that's nice. Do I have something like that? That's easy, huh? Okay. Done. Okay. Not bad. Not bad. What do I do here first, Parker J? I know it's going to be plus or minus, right? Okay.
But the top, you square root it.
Square root the numerator, f to the 10th, and you square root the denominator, because it's a fraction, right? The square root of a fraction just means the square root of the numerator over the square root of the denominator. Okay. Well, don't make it harder than it has to be. What's the square root of 121?
11.
11. Okay. So I know it's going to be plus and minus. Square root 11. What's square root of 100?
10.
10. What's what? F to the 5th, right? Because remember, it takes a pair to get it out from under the radical sign. And how many pairs of f's are there in f to the 10? There are 5. There are 5. So f to the 5th. Okay? Nice. What if it were f to the 11th?
We're going to have,
Well,
we'd have to have a root.
you'd have to still have a root f in there, right? Because if there are 11, I've got 5 pairs that I can pull out, but I'm still left with one underneath. Does that make sense? Now, that's not the answer. Let me take that back. I'm just saying if it were f to the 11th, 5 pairs, so I can pull f to the 5th out, but I'm still left with one in there. What if it was f to the 23rd?
Then you have 11.
Then you have 11.
So it'd be f to the 11th times root f, right? Because there's still one left underneath. All right? That was easy.
What's the answer?
10
F.
f to the 5th over 11.
I just wondered.
Plus or minus 10 f to the 5th over 11. All right. State whether or not the 3 given numbers could represent the lengths of the sides of a right triangle. how do I find out? I mean, what do I do?
If
Cameron?
you square all three of them.
Square all three of them. Okay, all right, help me. There's
So-
more than that, right? It's more than just squaring all three of them. What?
So
A squared plus B squared.
Okay, wait, hang. I'm almost done. Cameron, I'm sorry. You said, what is it?
T squared is 225.
I may have to go to Dylan here. What are you doing? Why are you squaring these things? What are you trying?
Because you're gonna add 15 and 20 squared.
Okay, you're still not getting there for me.
15
Explain to me, talk to me. What are we using to figure this out? Okay, Cameron says a squared plus b squared is equal to c squared. And what's this called?
Pythagorean theorem.
Pythagorean theorem. Okay, so now, Cameron wants to square 15 and what else?
And 20.
Okay, do you want that to be b or c? Okay, good, because remember c is always the longest, all right? And then 25 squared. So what do you get?
225.
225 plus 400
is 625.
is equal to 625. Is that true?
Yes.
So is this a right triangle?
Yes.
Yeah. Okay. If it's a right triangle, then a squared plus b squared equals c squared. That's true. If a squared plus b squared equals c squared, then it is a right triangle. Okay. The converse is true of those two things. Okay. All right. Nice job. Oh my. Ooh. Nice. What do we do? What do you think? Okay, you're just writing it down. Well, the first thing I need to do is simplify all these radicals as much as I can. Okay? So, I'm just going to deal with 7 over root 2 first. That's root 7 over root 2, but what's wrong with that?
You don't want to square root on the bottom.
You don't want to square root on the bottom, so how do I get rid of it?
Multiply by root 2 on the
Good. So I'm going to get root 14 over 2. So now this becomes 2 times root 14 over 2. Now I'll deal with that in a moment. Okay, well, I know that you see that you can cancel out the 2's, but let's just deal with these radicals first. So now I'm going to deal with root 7 over 8, right? Root 7 over 8 is equal to root 7 over root 8. Okay? What do I need to do now?
You multiply it by root 8.
Root 8 over root 8. So that's going to give me root 56 over 8. But what do am I done with that?
No.
What, I can simplify what, Parker J?
Is it root 7,
No, what are you working on?
56?
Okay, so you want to simplify root 56 right on top? Okay, so I'm going to give myself some room here. All right, root 56 is what?
Root 7
Root 7,
or 8.
root 8.
And 8 is root 2 and root 4.
Root 2 and root 4.
And root 4 is 2.
Okay, so this is just 2. Okay, so it's 2
Root 14.
root 14, because I can't do anything with that. So now I've got 2 root 14 over 8, right? But what do I do with that? I can take the 2 and the 8 and cancel that. Now that's root 14 over 4. So this is plus 4 times root 14 over 4. Yeah, they're getting it. Okay. All right. Now, the next thing I'm going to do is I'm going to deal with this root 98. Okay? Root 98. Any ideas?
49,
49.
Root 2, root 49.
So root 2 and 7.
So root 2, this goes down to 7. All right, so I'm just going to get minus 1/2 times what?
7 root 2.
Nice, 7 root 2 over 1, right? Okay. All right. Now listen, I'm going to stop here because this video is not going to go any longer. It's not going to let me. So I'm going to have to pick it up on the next video. All right? Cliffhanger. You don't know what's going to happen. You don't know what's going to happen. You're going to have to come back and see.